In this video, I'm going to pick up with a couple of real quick updates I've made to my system, and then move into the topic of what is it going to take for me to run FreeDOS on my system. I've started some steps maybe towards that, small steps, but I thought I would at least share what I've done so far and how I am approaching that. One quick update from the last video, I now do have my system running reliably and running well with an 11 megahertz processor clock and a 22 megahertz system clock. And really to do that, what I did is I replaced the priority interrupt controller down here with a -12 instead of a -5. And it's probably hard to see on here, but this is a -5, and that has to do with the speed rating. And it seems like that's actually one of the slower ones in the lineup. So there's some that don't have the suffix of a dash anything. And then there's a -5, which appears to be slower than the ones that don't have the suffix. And then there's the -12, which are the fastest ones that I could find. And so I pulled this chip out, put in a -12, and then I replaced this crystal up here with a 22 megahertz crystal. And the entire system is running great. So all aspects of it seem to be running just fine with that speed now. And so it really seemed like it was this PIC that was causing issues, at least the first set of issues when I want to go to a higher clock speed. And I had commented in a previous video that maybe this chip here, which is a versatile interface adapter, might be one of the next chips I would have to look at. I don't think that's actually the case, because now as I have this replaced, I can go through this via and access this SD card, even if I put in a 24 megahertz system clock. And this via keeps up just fine. All the SD card data comes back fine. Even at that speed, this communicating to this nano through SPI through that via, that's all working fine. At 24 megahertz, however, I do run into an issue that this nano doesn't appear to be able to keep up with the SPI calls to get mouse and keyboard data. Either there's something along the way signal-wise I could improve on the integrity of that, or it's the actual nano just can't process and get the data out fast enough when those SPI calls come in. I am going to try putting in a nano every in here. So my understanding is that's basically the same drop-in footprint, pin compatible, but it has a slightly faster processor. And so I'll see if that makes a difference. If I can get it up to a 24 megahertz system clock, great. If not, I'll probably be content here with the 22 megahertz and just run with that speed moving forward. And I do have some other things that I need to look at in the future as far as wait states and the ready signal and things like that. But as far as the build is right now, I am going to be running with the 22 megahertz system clock. Maybe something else I would show is this win.com that I've been working on. And basically what I've done here is I've just made it so that I can grab, well, first of all, mouse movement, but you saw that in a previous video, but now I can actually tell if a mouse button has been clicked, and then based on that button do something. And I'm actually checking coordinates of where you click. And so if I click just anywhere out in my, basically the screen here, what it'll do is just draw a square box, and I'm not doing that in this actual video clip, but I can click anywhere and get a little green box. But if I click on the start button, then it actually brings up this little start menu, and if I click on that top item, then I pop up another, basically a rectangle showing where I could then load up, some other dialogue or application or something like that. But really all I'm doing here is I'm just trying to tap into mouse events and be able to register and understand when am I clicking, where am I clicking, and what do I do when I click in different spots. Maybe moving into really the heart of this video though, I thought I would get into this again, and I've shown this graphic, and up to this point, I've said that really all of this is homegrown. So the hardware I've built, that's pretty much a homegrown solution. The BIOS, I'm doing that really from the ground up. I'm implementing, all the different interrupts and the support I need to really get an operating system running on top of it. And for the operating system up to this point, I've been doing my own thing. And then I've been writing C++ code for applications that I then include. And so all of that is homegrown. I'm not leveraging any existing BIOS or existing operating system or existing applications. But I would like to be able to do that. And maybe the first thing I want to dive into is to see if I can get FreeDOS running on this system. Now, I don't think I can just take FreeDOS, off the shelf as it is, already compiled and download it and try to get that to work, because I have too many differences in hardware, and I definitely don't have all the BIOS interrupt support that I need to have to run FreeDOS. And I'll have some limitations with my video card, and I have other things that I don't have in place yet, like a second capable timer, a millisecond capable timer on my system yet. Just little things like that I'll have to be working on. And I don't know what all I'm going to need. I just know there's going to be work. So I thought what I would do is try to get an environment set up so that I could develop and build my own FreeDOS, my own flavor of that, take the source that's there and then modify it to really work with the hardware that I have, and to maybe dissect it a little bit and see what interrupts is it using, things like that. So what I can do now then is look at what is my development environment that I'm going to work with. When you go download FreeDOS, the source code, it's already got all the batches and the make files and everything, so that if you want to just kind of use it as it is and build it, it actually isn't that hard to do that. So that's kind of the environment I set up here. And what I started with is VirtualBox, and I grabbed VirtualBox, the latest version as of today, which is 7.0.6. I then downloaded FreeDOS, the actual installer. I think it's the FreeDOS Live, I think is what is labeled, or something like that. It's a 1.3. And I created basically a virtual machine on that VirtualBox. I then installed FreeDOS. I then went into FreeDOS that was running on that virtual machine, and I added NASM, so that is the assembler that I'll be using. And then I installed Watcom, and I grabbed Watcom version 1.9. So some of the previous videos I've been using the version 2.0 or 2. something. But here I'm going to kind of stick with the 1.9. I was running into some issues with 2.0, and I don't know if they were just some bugs or what it might be, but I'm going to stick with the 1.9 for this, at least for the time being. I then went and downloaded the kernel, but basically FreeDOS, all of it. And my primary goal right away, though, is to get the kernel built and see if I can try to understand what it's going to take to get that kernel running. This is before I would get to command.com, which I think is for FDOS is called FreeCom. But I'll have to get to that at some point here. But maybe for now, if I could just start with, can I get the booting working and the kernel loaded and running? And then from there, I could load my own command com, or I could move into this other FreeCom or whatever it might be. I grabbed a copy of that, put that into my DOS virtual machine. And one of the first things you have to do if you want to then actually be able to build this is you have to edit a file that's in that directory, and that is called config.bat. And in there, basically, you've got to point to all the proper, where is your assembler, where is your compiler, and a few other options. So I went through this batch file, configured it for where I had all of these different tools, the assembler, the compiler, actually installed in my DOS system. And then there were two additional things I had to do. I had to also grab this country. So I went up to GitHub and went to fdos/country, and I grabbed that and put the contents of that into the basically a country folder that was within the previous source code that I downloaded. And then I had to modify a file off to the right. And this file is the make file inside of the kernel subfolder. And there's a syntax there. You can see it in the upper right, this line 46, where it says cd ... $, and then it gets to this and. And that syntax was not working with my setup. And my understanding of that syntax is if the CD, the change directory, is successful, then go ahead and proceed with the make. and that and syntax wasn't working with my setup. So I just simply put them into separate lines, and I just say cd into that directory and then do the make. So I suppose technically if the cd fails, then make is gonna maybe cause some problems, but this resolved the issue, and I was able to then to properly build FreeDOS, at least the kernel here, for hopefully for my system at some point. And I'll jump over and walk through that in just a second. Maybe one comment before I do that. The next step, and this is something maybe in the next week or two I can get around to, is trying to get an IDE interface working. My goal here is to take this card. I have two different connections. One goes through basically a buffer and one does not. Try to get a CF card working, and that's something I can then load a file system like FAT16 onto, and then I can copy over the necessary, for example, kernel file here that I could then boot up off of my flash ROM chips and then hand control over to the kernel coming off of this CF card. So that is the direction I'm headed. Now maybe let me just jump over and show you some of this stuff in my development machine. So here I have this virtual box, and basically, I came in here and I added a new virtual machine, and maybe a couple of things to point out. I did point to basically creating a drive, a virtual drive here that is this FreeDOS.vdi that I created, set it up as a 2 terabyte drive. I also added an additional drive, but this one, when I added it, I chose not the VDI format, but instead this VHD format. And the reason I did that is that when I shut this VM down, I can actually have Windows attached to that VHD, and I can then write to it, read from it, etc. So that allows me to turn off this VHD or this VM, attach the VHD, copy in installers, source code, whatever I need to get into that DOS environment. Because there isn't a real convenient way to get files in and out of this DOS virtual machine. Networking out of the box really doesn't work. You have to do some work to make that actually be usable. But this using a VHD seems to be a pretty convenient way of getting stuff in and out. And then I also have this I guess secondary device is just the installer, that live, basically CD is what it's showing up as. And so now if I go ahead and I turn this on, I'll bring up this VM and maybe I'll just minimize this and get it out of the way. So it comes up. I'm going to go ahead and just proceed with this default option. And now I'm into my virtual DOS. So if I take a look, I have my C drive and I can do a directory, and you can see that in here I have a folder, development folder, and in that development folder there's my NASM. So here's all of my NASM content that I need. If I come back out here, I also have Watcom. So here's all my Watcom content that I'm going to need to be able to do that work. And then on my D drive, this is where I actually put in the source code that I downloaded for FreeDOS. So now I have this FD kernel. This again is that VHD. So this is where I had attached it to my Windows host, downloaded the source code from GitHub, put it over here, and that's what I'm now working with as I spun up this VM again. But now inside of this, here's all the folders and the batch files and the make files. And that first one I mentioned, you have to grab this config.b, copy it over to config.bat, and then you have to edit it. And in that, put in all of your specific things for your environment. So I'm using NASM, and then I come down here. These are all commented out, but I'm going to set my compiler to be Watcom. And there's some more Watcom stuff I have to include down here. I'm not using this UPX, which I think is something for compressing files, which I'm not worried about compression or file size at this point. What am I using for a linker? What CPU am I targeting? And I, for now, set it to 186. These are the three choices I saw in here. I don't know if 286 is a valid option or not, but I set it to the highest that I knew I could support, which would be a 186. I can't support 386. But basically went through this file, configured all that up. And then, like I mentioned, I also had to go into the kernel folder, and I had to edit the make file that was in there and find that line that had the syntax that it didn't really care for. And that was this correction that I made to it. I also went and downloaded then the country information. So if I go into this folder country, I had placed these files in there. It was looking for this TB1 file. After doing all of that, though, I can now come in and I can run some of these other batch files. I think they're BATs, and maybe I'll start with a clean. But now I can go ahead and do things like a build. So I can run this build file, and it goes through everything. And initially when I was doing some reading on this on the internet, all the posts I was seeing is that this was, people were having problems getting this to work without all kinds of errors. So I don't know if I just got lucky or something's been cleaned up in the source code, the build files, whatever, but this is building, it seems like just fine for me. And there's a folder then here called bin. So now I can change into that bin, and I can do a directory, and I can see that these files have been updated. So any of the ones that say 9:49 a.m. right now, I can just put these in order of date, I guess. You can see starting with sys.com down to the kernel sys, setver sys, all those files were built successfully. And so I think that is my kernel now I can be using. That kernel probably isn't going to work as it sits on my system yet. I've got to get storage working. I've got to get the actual boot process so that I can pull from the CF card, get that support into my BIOS. But I need to update the BIOS, read from the CF card, get this kernel loaded, and then figure out, what is the kernel looking for that I don't have. And maybe what I'll do is I'll just go back to GitHub for a second. And here is this kernel so I'm up in this FreeDOS and looking at the kernel. What I can now do though is I can go pick one of these, whatever it might be, and look at what is actually in there for source code. What is it doing, and is there something I need to adjust for my environment, my hardware, or something like that. Something else I can do is I can also look at where are interrupts being called. So I can come into some of these and just see, is there some type of an interrupt that I need to do something with. And, it might be as simple as just searching for int and see, is there anything there? And I'm just randomly picking some of these. I've not spent a lot of time going through this yet. So here's some calls. So here I'm going to call int 16. So that tells me I need to get interrupt 16 working. I'll zoom in a little bit here, but I need to get interrupt 16 working on my system in the BIOS. And if I keep going, there's another int 16, there's an int 29 I'm going to have to get supported, and int 10, which I already have int 10, that gets me into the graphics stuff, but now I have to look at what is, do I have 0e, that would be the function within the video services that I want to call, do I have that function implemented or not? But now I can start looking through this and seeing, what are the actual interrupts that I'm going to have to support the different functionality that I'm finding inside of this. And so I'll start working through that and see if I can kind of get to that point where that is workable. And I can see there's like FAT file system stuff, which is great, so that I don't have to implement a FAT file system. It's already done here. Again, I can look through this, and I would assume from some of the C code, there's also int calls and a lot of data types here, but I can go through and see if I can figure out where are they raising interrupts from C code, which I assume is being done somewhere. I could be wrong there, but and I'll have to see how they're actually raising interrupts from here. It might be different than how I was doing it in my C++ code before, but that's all stuff I've got to learn and kind of figure out. But I've got the source, I can build it, I can now start to adjust it, I can continue building interrupt support in my BIOS, and if I can get my CF card and access to that CF card working, I think I'm going to be pretty good step closer to getting FreeDOS running on my machine. And if I can get to that point, then the goal would be that I have, this type of experience that I should be able to run, where I can boot up and start working with some of the stuff in here. Lots of work ahead of me. I would say that when I get into like this the FreeDOS kernel that I downloaded the source code for, and I go look at things like that build, there's a lot of stuff in here that it's doing, and it's calling other batch files. And you can see, when I did that build, it goes through, and in this case, it's already built. So I'll do a clean, but then I'll do a build. It's going through a lot of things here, and I don't necessarily understand everything that it's doing. I know it's doing some compiling, and then it's doing some assembly of that. And I've not in the past worked with these separate, taking all these separate files and bringing them together into a single output, but whether that's called linking or whatever it is, that's something I'm going to have to learn more about here. But more to come. This is probably going to be a slow process for me, so I probably won't have videos posted as frequently, just because I've got a lot to learn here, and I'll just kind of periodically post as I think I'm making some progress or learning something. And more to come then. Thanks for watching.